Hey, how are we? So, after watching this video, hopefully you'll be able to define and find the discriminant of a quadratic and use the discriminant to determine the nature of the roots of a quadratic. So, let's begin with a question. What are the roots of a quadratic? In general terms, what are the roots of a quadratic? The roots of a quadratic are the x-intercepts of a quadratic, where the quadratic intersects with the x-axis. So this here, this intersection with the x-axis is a root. This other intersection here is also a root. This one and only intersection here is also a root. And then when there isn't an intersection with the x-axis, the roots are said to be imaginary. So you basically have three scenarios for the roots of a quadratic. In one scenario, you have two real roots. Two real roots. And that's because you have two x-intercepts. In another scenario, you have one real root. And then in another scenario, you have imaginary roots. All right? In the scenario here, where you have these two equal roots, you could see that the roots are not equal. And in the scenario here, the roots are said to be equal. So you could just jot that down in your notes, and we'll talk about what that means, not equal and equal a little bit more later on. All right, what's the discriminant? The discriminant is the name given to the expression that appears under the square root sign in the quadratic formula. So here's the quadratic formula. The discriminant is the part under the square root sign. So b squared minus 4ac is what we call the discriminant. Okay, example 1. What is the discriminant of 2x squared plus 10x plus 2? So recall what we just said. The discriminant is b squared minus 4ac. So, oops, let's ignore that. This is a, this is b, and this is c. So a equals 2, b equals 10, and c equals 2. So you substitute into the formula for the discriminant, you get 10 squared minus 4 times 2 times 2, and you get 84. So the discriminant is 84. So basically finding the discriminant is just performing a set of arithmetic operations. You square b, and then after squaring b, from that you subtract 4ac. So you have to remember that b squared is equal to, I'm sorry, you have to remember that the discriminant is equal to b squared minus 4ac. Okay, the discriminant is important because it determines the nature of the roots, whether they are real or imaginary. So remember in the earlier slide we talked about you get imaginary roots when you don't have any x-intercepts. Well, if the discriminant is negative, then the roots are imaginary. So if you have a discriminant that's negative, the parabola will not intersect with the x-axis. If the discriminant is 0 or positive, then the roots are real. Then you will have an intersection with the x-axis. So if b squared minus 4ac is less than 0, that means if the discriminant is negative, then you have imaginary roots. If b squared minus 4ac is greater than or equal to 0, then you will have real roots. Determine if the roots of 2x squared plus 10x plus 2 equals 0 are real or imaginary. So let's find the discriminant. The discriminant is 84. Now, based on what we just said, let's go back to the previous slide. Let's pull it up. It's right there. If the discriminant is 0 or positive, then the roots are real. Well, what's the discriminant? It's 84. It's positive. So we know that the roots are real because the discriminant is greater than or equal to 0. So the roots are real. There is an intersection with the x-axis. And you know, why don't I just actually, let me go back to the previous slide. Let me pull that up again. Let's look at the graph of this on the graphing calculator. Let's look at the graph so you could see it for yourself. Type in 2x squared plus 10x plus 2. Whoops. 2x squared plus 10x plus 2. And then you hit graph. And you could see by looking at the graph that you in fact do have real roots. You see the two roots right there. And by the way, there is a way to find the actual roots. If you go to second, trace 0, the roots are also called the 0. If you go to the left of the root you're looking for, press enter, and then go to the right of it, press enter and enter again. See, the root is like negative 0.20871122. That's the actual root. The discriminant just tells you that you're going to have two roots, and one of them is this number here. So the roots are real. The discriminant is positive, and then you can see it here on the graph. Okay, let's move on. I think we're running out of time a little bit. Let's talk a little bit more about the nature of the roots. So basically, you have two choices when it comes to the nature of the roots. They're either real or imaginary. All right? Then, if they're real, they're either rational or irrational. And then they're either equal or not equal. Let's talk about what we mean when we say rational and irrational. So rational is just a number that can be written as a fraction, and it can have a repeating decimal. So for example, 10 over 2 is a rational number. 0.3333, you have a repeating decimal, that's a rational number. What is an irrational number? An irrational number is a number that cannot be written as a fraction. Let me correct that. Irrational is a number that cannot be written as a fraction, and it has a non-repeating decimal. So irrational. Let's make that text smaller. Cannot be written as a fraction, non-repeating decimal. So for example, radical 2 is irrational. Pi is irrational. Radical 3, and so on. Radical 7 is irrational. Radical 4 would not be irrational because radical 4 is 2, and 2 is a rational number. Okay, example 3. Determine if the roots of 2x squared plus 10x plus 2 equals 0 are rational or irrational and equal or unequal. All right, so this is just the same example from before. The discriminant is 84. Whoops, I don't want to look at the answer yet. So there is basically a way to know all that information, and I wrote it down for you over here. So if you want to determine if the roots are rational or irrational, take the square root of the discriminant. If the result is a rational number, then the roots are rational. If the result is an irrational number, then the roots are irrational. So basically, what I'm saying is, take the square root of 84, square root it. What's the result? What do you get when you square root 84? You get an irrational number, right? Take the square root of 84, square root, no, I don't want to do that there, square root, let's erase that, square root of 84. See that? It's an irrational number. You have a non-repeating decimal. So since square rooting the discriminant gives you an irrational number, we know the roots are going to be irrational. To determine if the roots are equal or unequal, well, by looking at the graph, we could tell that the roots are not equal. So that's one way to do it. Look at the actual graph. The roots are different. You could see that by looking at it. But there's a way to also tell from the discriminant. If the discriminant equals 0, then the roots are equal. If the discriminant is greater than 0, then the roots are unequal. So the discriminant is 84. That's greater than 0, so the roots are unequal. Let me just enlarge this. By the way, you should copy this slide into your notebooks, the one on the right. So our final answer is the roots are irrational because the square root of 84 is an irrational number, and the roots are unequal because the discriminant is greater than 0. All right, so that's pretty much it for today. I hope this video helps. Take care.